Assalamu alaikum. I welcome all of you to the course on organic chemistry. Today again we will be studying the resonance. So what was our goal? What is our goal? Our goal is to understand that why those type of the molecules react differently. From differently I mean that why they are not pure amine or pure alkene, okay, or why they are not reacting like amines or pure alkenes or pure amines. But those type of the molecules, they react like they behave like amines, and they can also behave like alkene, but this thing never behave like pure amine or pure alkene. So for this purpose we want to study the resonance. That will help us to understand that why those molecules have some different reactivities and what are their actual reactivities and how would they react in a chemical reaction. So we will be studying some tools for the resonance. When we understand those tools, then we will be able to understand the resonance. And the resonance, after understanding the resonance, our main goal will be covered, and that is that how molecule behave during a chemical reaction. So during resonance, what happens? Electron moves, okay, but which electron moves and where they move? So let me tell you one thing, that in reality no electron movement occurs. The resonance is just a phenomena to make us understand that what the actual structure or the real structure of this molecule is, okay. So this back and forth doesn't occur in reality, but now for us to understand that how this molecule will behave, we need to follow some rules of resonance. So before the rules of resonance, we just I just want to make you understand that how the electron moves and which electrons actually moves. So during resonance, the pi electrons moves or non-bonding electron moves, okay. Now the second question is that where the electron moves, okay. So the electrons, those electrons will move to a vacant space, okay, or a vacant place available to them. This concept will be clear to you by practicing some examples or understanding a little bit detail of the resonance, okay. Where the electron, which electron moves? So pi electron moves. Which are pi electron? Those electrons which are part of a pi bond. Non-bonding electrons, what are those? So they are also sometimes called as lone pairs. So those are those moves. Where they move? They can move across a double bond, or they can move to some vacant orbital. So again, our main goal is to understand those structures, okay. So to understand this, we need to understand again some other things. So when we look to those structure, this alkene and this type of things, there are some arrows. This is an arrow. This is an arrow, like it's a bent type of arrow with the spear-like head, and this is another two-headed arrow, and this is another molecule. So let first understand that what this arrow is doing and what does it means. So first thing which we need to understand is the pi bonds will move during resonance, or non-bonding electron will move. Sigma or sigma bonding electron movement is very rare, so we will not be discussing them right now. Now this arrow, what does this arrow shows? this arrow has a tail and a head. What does the tail shows and what the head shows? Okay, so as you know that this bond, the pi bond, it is composed of two electrons. This is one electron and this is the other electron. So this arrow is drawn in such a way that the tail will show that these electrons are moving. The tail will show us that those electrons will move. The head will show us the place where the electron will move. Okay, so those two electrons, which are pi electrons, because they have formed a pi bond, so they move and sit on this carbon. Okay, so those electrons which are initially the part of a double bond, they move from the bond and sit on this carbon. Okay, so what happens as this carbon is neutral and this carbon is neutral, I mean they don't have any charges or they have zero charges. Now what happens when the bonding electrons move away from one carbon? It will acquire a positive charge. What the positive charge is? Deficiency. And the other electron, to where the electron moves, a pair of electron moves, it will acquire a negative charge, which is indication of surplus electrons. So here I would like to mention another arrow which I just said, this double-headed arrow. It shows two resonance forms. So it is a little bit complex thing to understand, as this arrow just shows us that both these molecules are same. It shows two forms of a same molecule. Okay, or in fact it just shows one molecule. This is one molecule. So on either side of this arrow is the resonance form of the molecule. Okay, so let us now study that how the electron moves across the double bond. Okay, now I am going to draw the resonance structure of this molecule. So another thing which need to be noted is that electrons will move only when the double bond or the pi bond is conjugated with the single bond, or you can say for simplicity, when in between two pi bonds there is a single bond, then resonance can occur. So in fact there is no resonance. The molecules all the molecules have a stationary electron cloud, but the concept of resonance, which in reality doesn't exist, but we need to understand it, because it will help us to understand the reactivities of the molecules. At the end of the lectures you will notice, or you will see, that these arrow pushings or this back and forth movement of the electron is not necessary. It is not that much relevant in scientific world, but it will help us to understand the reactivity, or which our goal is. So let's us move those electrons. Now here the electron moves here. Okay, as those two electrons move here, what will happen? The valency of this carbon will exceed. As you know that it forms 4 bonds, and now again a bond will be formed between this carbon and this carbon as those two electrons comes and sit here. Okay, so we can and what will happen next? Now as soon as these electrons arrive here, at the same time immediately these electrons will come and sit on this carbon. Okay, so the other structure or the canonical form is like this. Okay, the advanced version of the resonance or delocalization which you will find in the modern concept of resonance. For that you need to see the link shared below. Okay, this is a basic course, so it's important for those students who are new to the organic chemistry. Now I have to write it like this. So those electrons come and sit here and it will form a double bond between those two carbons. Those two electrons now sit on this carbon and will create a negative charge. As you see, the tail of this arrow shows a transfer of electrons or the movement of electron from this bond. As the electron moves, this carbon will acquire a positive charge, and these are the hydrogens to complete the valency. Now as you see that those electrons move from here, and here a positive charge came and here a negative charge comes. Initially there was no double bond here, but now there is a double bond. Here it was a single bond and now here it is a double bond. So these electrons, this is the movement of the electron, the moment of the electron, which shows us the resonance, that this part is positive and this part is negative. So step by step we will go to little bit moderate concept. Okay, but there is another thing which I would like to mention. This is the resonance arrow, but another thing can also occur. The same electron can move in the other way. I should write it like here. Okay, so what will happen? Carbon, this, the space is less, so I need to write it in a short space. This is negative, this is H, this is the double bond, and now this acquire a positive charge, but still I am doing it randomly. We don't know why this acquire a positive charge and the other negative charge. It is the problem which we will be dealing in the lecture. In its later on we will be dealing with this, but right now I just want to make you understand that how the electron moves. And if this is boring for some students, so if they want to study a little bit advanced material, so they need to click on the link shared below. Okay, so here the two resonance forms are created, or they are. One resonance form is this, and this is the other resonance form of the same molecule. But still we cannot translate. I am not translating it to you because my aim is just make you understand that how electron moves. Okay, why the electron moves? For that again I am telling you, you need to study the my other video lecture series, the modern concept, and there you will find the delocalization or resonance topic, and then it will be clear to you. But this is designed for the very beginner students. Okay, so this is another thing which is we need to understand. Okay, now as I told you that the electron moves. Now we just saw that pi electron moved across a double bond, or electron move across a pi bond, but the electron can also move to a vacant orbital or a vacant space. So again, I should write this is a double bond, loose electron, pi electrons are loose electrons. Now this is a CH2 and this is plus. Okay, the plus means that it is electron deficient species, or you can say that it is just a vacant p orbital on the carbon atom. I hope you will see this color, or I should rewrite on with this blue marker. Okay, so what happens, these electrons move and sit here and form a bond to a vacant orbital. You should not write like this. Okay, in fact the electron comes and you need to draw the head right in the middle. Okay, so the electrons move and will come here. Okay, so what happens, another resonance form is produced, and this is the resonance form. As electron left this carbon, so it is positively charged, double bond is produced here, and the valency of this carbon is satisfied, and it is now neutral. Okay.